There is a digital clock here, fellows. This is a digital clock. We have got here two ports here, as you can see on interfaced on that board. This port controls the segment, the selection of the segment. Is out of the 8 segments, which one we can select, because all these segments are multiplexed together. So at a given time we can select one segment, and this is so because we have just 8 bit of data that is being fed at a given time from the controller to the 7 segment, which are again of 8 bit each. We cannot give 16 bit of data or 32 bit of data or 64 bit of data. Only 8 bit of data can be fed to this at a given time. So this is being fed through this port, the data port, and this is the selection port, that is the segment selection port. So, and if we see closely, they are being driven and they are being controlled by this controller unit. That is the controller, as you can see here. This is the controller. This one here, this one is the controller 89S52. So this port, as you can see here, this is being going to this port 3. This is the port 3 of this controller. So basically we are sending the data through port 3, and this port, this one is going to the port 1. So basically we are controlling the selection of this segment using this port 1. So, and then the program is flashed using this flash cable that I have here through this 8-bit controller that I have here, which is being used to flash the program from the binary, basically the hex file from the system to the controller here, using this in-system serial programmer that I have here. This is a serial programmer, not a parallel port programmer, because this is going to straight to the USB port here, as you can see. This one is going to the USB port, so hence is the serial port that I am using here, COM port. So now if we look at the code here, here if you see here, the first, as I have told you before, the select is for selecting the P, that is going to port 1, and this is for selecting the segment, and the second P3 port is for sending the data here, and these are the codes for that, the hex codes for 0 to 9. And if we look at the code now here, basically I am using this timer interrupt. So basically timer 1 I am using. So basically I am loading it with the count here. The count here, as you can see here, the timer 0 count here. So basically some count has been loaded, and when the timer overflows, I will have to initialize it first and then start the timer here by enabling, and after that enable the interrupt, basically, so that I enable that interrupt, so that I get that timer interrupt. So when it overflows, the timer overflows, then the code hits this interrupt subroutine here. This is the interrupt subroutine here that we are calling here, the timer 0 ISR. So here is the main thing that we are doing here. So basically every time when the timer interrupt hits here during the time of overflow, we are going to execute this piece of code here, which will control the hour, minute, and the second hand. So basically some logic has been used here to do that. So basically I am using some logic to do it. Now if you see the important part of it, so firstly for each of these segments here, you can see here I am selecting first the first segment. First select this segment, then send the data, and then hold it for some time, say for some time, for which I am using this delay. Delay loop. This is the delay loop, you can say. Then same thing for the hour count 1, minute count. For each of these segments, I am just selecting first the segment and then sending the data out to it. And this entire setup, since it's basically a whole type display, and that's the important point to be remembered, since it's a whole type display, I have to hold this entire display data for some time, and due to which this entire display setup has to be encompassed inside this loop that I am using, this outer loop. This is since we have to hold this display for some time, due to which I am keeping this entire display inside this outer loop that you can see here. Otherwise, if I don't give this loop outside here, then the display won't be proper and the flickering will come. That is, the change in this display would be very fast. You cannot observe anything, and the user cannot observe anything. So basically, since this delay, firstly this delay that you can see here, this 100, 100, 100, they are so small that the flickering would be very much small here, and that cannot be observed by the naked eye. So basically I am sending the data out serially, that is, the serial display is happening basically, but basically due to the persistence of vision of our eyes, we cannot see the flickering of the data. So what is happening here is that I am displaying it one by one, but since the delay is very very small here, as you can see, 100, 100, 100, so basically that's why the flickering is not being observed, and all we can see here is that the display is constant. And this outer loop ensures that as you can see here, ensures that we hold this entire display for some time. And this loop, that's why this loop is the most important part of this project. So basically that's about the code here. And again, after this thing has been done, we again start the timer here, and again this interrupt subroutine has entered here, and again this subroutine will be hit after the timer overflows after 10 millisecond delay, and this way it proceeds. This way I am working it out. So I hope that everybody likes this video, and maybe try up nice things out themselves. Thank you.